Good morning, students. In the first module of this subject, we already discussed the formation of natural soils. So, in the last lecture, we discussed about the weathering of soil, the erosion, the transportation aspects, and now today we will be discussing about the deposition of various soil formations, and as well as the just glimpses of post depositional changes. So let us start with the deposition. So here in deposition, the deposition of sediments either by air or water, it is the similar as we have already seen in the case of transportation. So if the stream velocity and turbulence fall below the values which keep the particle in suspension, then what happens is that the particles will settle. So the sediments may be deposited, which are deposited, are carried away by the melt water when the ice is melting in if you go to the colder areas. Also, the material in solution can precipitate when exposed to conditions of changes in temperature, or there is some change in the chemical composition, etc., or even by the evaporation of water. So these are the various means by which you can find the deposits, or this is how the deposition occurs. So here we can see that the sediments either can be divided, the deposited sediments can be divided either as chemical or by biological means. The first one, that is one section, and another section is either by the mineralogical changes, or if they are formed from the rock fragments. So the second case, the one which are formed by mineralogical changes or from the rock fragments, are referred to as detrital or plastic deposits. So most of these deposits, or the deposition of sediments, in most of the areas it is actually a cyclic deposit, or some cyclic changes lead to the deposition of the sediments. The first one is the periodic earth movements. The second one is the climatic changes. The climates change in various cycles, and that length also vary. So that has an impact on the deposition of the sediments. And then the cyclic shifting of tributaries on delta, and also the periodic volcanic eruptions or volcanic activities on various areas that also contribute to deposition. So the deposits formed can be either vary, the thickness of deposit can vary from like some millimeters or even to hundreds of meters, and also the periods of these changes or of the cyclic changes can range from months to years or even thousands of years, and only either one sediment can be formed, or many types of sediments or stratified deposits can also be formed. And the best example of sediment by cyclic deposition is the wound clay. So let us look into detail about the characteristics of wound clays. So moving into the characteristics of wound clays, they are actually formed in the glacial lakes by the melting of water. That means when the melt water carries these sediments, and they are formed in these glacial lakes. So it has consists of two layers. I will show you the figure of wound clay. It has two layers. The first layer is light colored layer, which has the summer deposited clay silt, and then it has a darker layer which is the winter deposited clay silt. So a mixture of two layers, the summer clay layer and a winter clay layer. That is how the wound clays are formed. So during the spring and thaw seasons, spring and summer, the glaciers melt, and this clay and the silt laden meltwater moves to the lakes, and then this deposit is formed. So the coarser silt particles, they settle to form the summer layer, and these fine particles, which is just will take time to settle, because they will be in suspension in the water, and as the winter comes, and this smaller particles also will settle down to form this second layer. So this wound clay is actually a combination of alternate layers of light colored fine grained particles as well as the dark layered fine grained particles. Checking the other aspects, the strength parameters, if you see the horizontal valves, the shear strength is quite higher compared to the across the valves. That means across the vertical direction. Also, the hydraulic conductivity in the horizontal direction is also higher compared to the vertical direction, and the areas where these are usually found are the northeast and the north central United States, eastern Canada, etc. So here I will show you a figure of a wound clay, how this looked like. So it's a cross-sectional view of a wound clay's thick deposit. You can see here. Here you can see that light colored layer is also there, and a black, very dark layer is also there. So this light colored layer is actually the clay deposit in summer, and this clay is silt in summer, and this is silty clay which is deposited in the winter. So the light colored, it has more of silt particles, and this dark color, it has more of the clay particles. So this is the cross-sectional view of wound clays. It's actually collected from New Jersey Meadowlands. Now moving on to some other aspects of deposition. Most of the complex soil deposit process occur along the coastlines, the estuaries and shallow shelves when compared to the shorelines. Also, the soil deposits include the foreshore sand and gravels, which are sorted by the wave action, organic deposits, and also the clay preserved in lagoons, offshore fine sand, muds, etc. We can see that river channels may be over deepened and soft sediments then accumulate to form the buried valleys. That also can be observed in case of rivers. And most of the coastlines and estuaries of the world, they were subjected to sea level changes in the quaternary periods. Every quarterly they are subjected to the sea level changes, and it was found that about 6,000 years ago, most of the post-glacial rise of sea level is ceased, and it has a worldwide impact on the current coastal formations. So all these aspects influence the deposition of the sediments. Now moving on to the some biochemical sediments or biochemical deposits. They actually consist of two kinds of materials actually. So first one here that I can show, here you can see two figures. First one is a Dog's Bay calcium carbonate sand, and the second figure B, is the diatoms observed in Osaka clay. So these are the microstructural images of the clay particles, and the first one is carbonated sand and second is a clay. Okay, so here the first example is actually the calcium carbonate sediments, which are made of calcite, and they originate from the shells of organisms in deep sea. So that is one kind of deposit, and another deposit is from the microfossil, and it has significant amount of microfossil which is due to the depositional environment. Okay, so examples of such microfossil clays or microfossil deposit sediments are usually it is found in the Mexico City, Arik, as well as Osaka, and here in the figure you are seeing the Osaka Bay clay, the same image of the Osaka clay. So moving on to more onto the characteristics of this microfossil clays. So here moving on to the characteristics, the microfossil include diatoms such as the siliceous skeleton of eukarya cells. So actually what is this eukarya? It is actually forms the domain of life, that is bacteria as well as an archaea, and this eukarya forms one of the three domains of life. So all these cells, whatever I refer here, the eukarya cells or the radiolaria as well as the foraminifera, all these belong to the microfossil cells. So if you go into detail, you can search about this eukarya cells and all, you know that they are some kind of the cells which are formed from the fossil formations. Okay, So here what I want to say is that this microfossil clays include these are actually originated from such cells of organisms, microorganisms or any organisms either found in the continental sites or in the marine environments. So here this particular microfossil clays, they have the either the eukarya cells, either which is formed from the freshwater or marine environment, and that is actually this more of a silica material is found in that. Also some other micro marine environments also you will find this radiolaria, and that also has silica present in it. And another is the foraminifera category, that is the calcium carbonate shell secreted by this marine eukarya. So you just go into the details of this cell formations, this life formations, like this actually is more onto the biological side if you go to the microfossil and all. So just for understanding, you can go and search about this eukarya cells, radiolarias, foraminifera, etc. Exam point of view, just consider that microfossil clays are actually from the fossils of the living organisms which are either in the continents or in majority they are found in the marine environment. So they consist mainly this silica particles in the microfossil clay. Okay, and then the presence of microfossil has a great effect on the behavior of soil. Mainly the strength characteristics and other geotechnical characteristics deviate from the normally what we see, normal soil deposits. That means they have high porosity, the liquid limit is very high, the compressibility is unusual, and it has uniquely high friction angle. So some varying properties of soils are observed in microfossil clays. So earlier we have seen that in the transportation side, while streams and rivers they produce the deposits according to the grain size. You have seen various aspects of sorting and abrasion and all. Whereas if you see the glacial transport, they equally transport the fine dust as well as the large boulders at the same rate. And this materials, if they are found unsorted after the deposition, then it is called as till. Such materials are we refer to as till. And a mixture of all the grains is from boulders to clay is known as the boulder clay. So that mixture of larger particles, all the grain sizes from boulders to clay, we call it as boulder clay. And it is a difficult material to work with because these large boulders may damage the excavation equipments. So usually these boulder clays, you can see it is actually coming from these glacial movements, where irrespective of the size, the glaciers move the sediments. So another type of deposited soils. So already we have seen that seen two biological and chemical sediments such as the microfossil clays, and then also we have seen the calcium carbonate sediments. Now let us see another, and then we have seen till, boulder clay, and now we come across another non-stratified alien deposit which is called the loess. It is also a deposition form of soil, and it is a non-stratified form. So it is actually the most abundant quaternary deposit which is found on land. So it has the, if you see the composition, it has some fraction of clay, sand as well as the carbonates. So it is actually the origin of this soil is from the quaternary period, from glacial outwash or the deglaciated till areas. So it forms a blanket to the existing landforms. So this loess actually it forms a blanket. It acts as a blanket to the existing landforms. The deposit is like that. So if you see the thickness, deposits are up to 30 meter thick, and even some places it is more than 180 meter thick, and up to the thickness can vary up to 330 mm in various parts, like you can see in Missouri, Tajikistan as well as northern China. So you can see how deep this deposit can go. We are saying that it acts as a blanket, but that blanket is itself is a very thick blanket of like 330 meters thick. You can find this loess deposit. Now moving on to the general geographical depositional environments, you can see the deposition can occur in the continental side, that means in land, then mixture continental and marine, and then only in the marine. So there are three, the deposition, the geographical deposition can occur in these three sections. First one is continental, then mixed continental and marine, and then marine. Now, the continental deposits, they are obviously they are located above the tidal reach, and they include the terrestrial, the paludal, and lacustrine sediments. And then the mixed continental and marine deposits include the littoral and deltaic and estuarine sediments. Littoral means it is between the tides, the deposits formed by the tidal movements. Then marine deposits are located below the tidal reach, and it consists of continental shelves, continental slope and rise, and deep ocean sediments. So these are the various types of geographically how the sediments are we can categorize. Now here a table is shown how the various you can see the depositional environment of various soil deposits. So first you can see the transported deposits. You can see what are the agents. It is air, water, shallow river, shallow lake, shallow ocean, deep ocean, then glacier. And you can also see the type of the soil and also the texture. So what are the various types you can see here? If you see shallow ocean, as we were discussing here in marine deposits, that is estuarine, littoral, and shelf. And what are the characteristics you can see? Here estuarine is have a characteristic of silt and clay. Littoral, it is silt and sand, and if you move to shelf, then it is silt and clay. So various soil has various characteristics, the texture and the characteristics you can see. Also the residual deposits you can see tropical soil, saprolite, decomposed granite, colluvial soil, which is actually from clay to boulders, and also the chemical and biochemical deposits, also either by lake or sea. So various environment, what all kinds of deposits are formed and what is the texture is very well explained in this particular table. Now moving on to the very highly I have explained quite complex things here, and that can be put together into a very simple figure sketch here, that how you can simplify the depositional environment for sediments which are transported by water. So if you can see the mountainous erosions, then mostly they are boulders and cobbles which come from the mountainous erosions. Then if you go to the river valleys, then fluvial terraces, floodplains, etc., you can find some gravels as well. Then moving on to the lakes, lacustrine, estuaries, and estuarine deltas and deltaic regions, you have a mixture of gravel and sand. And then in the coastal cliff erosion beach deposits, obviously you can have a mixture of sand, gravel, as well as silt. Then as you go to the seas and marines, then definitely it is only the silty particle, and you have some clay as well. And then moving on to this entire region, that is from lake to ocean, the deposit is mainly clay deposits. So you can find only the clay deposits if you move to the coastal line. Then also you can find some organic plant remains, and once you move to the oceanic side, then it will have only the organic plant remains you can find, also some colloids and muds, and then skeletal remains. So that is how the variation it goes according to the transportation by water, how it varies from mountainous erosion to the ocean, what all kinds of soil deposits you can find. So next, so we have discussed about various aspects of soil deposits. Now after deposition, let us move on to the next topic, that is the post-depositional changes. So once the sediment is deposited somewhere, and when the humans encounter any activity on that particular terrain, it may, or for years that deposit will be there, and it will be obviously it will be exposed to a lot of changes. So that changes we collectively called as the post-depositional changes. So it can be either physical, chemical, or biological. So they occur because the young sediment is not necessarily stable. The sediments which are coming, they need not be stable, right? It can be fresh, so it can be exposed to new conditions, new atmospheric conditions, new physical or chemical changes, etc. And it is very important to have a good idea about this post-depositional change in order to know the properties, and in order to know the properties of the soil, as well as you need to interpret the soil profile for any construction activities, as well as the you must be very well aware about the geological history of the soil before proceeding to any kind of other construction activities, or to know the testing and anything. So this all this collectively comes under the topographic survey or the initial survey which we do. So it is very important to know the post depositional changes of a particular soil. So this also is an aspect which is very importantly we have to take care of when we do the soil exploration and all. So just I am giving some brief idea about the what are the changes which can happen in the sediments, and all this I will explain in detail in the next lecture. So some of this I have already explained in the other sections in the weathering aspects, like the weathering already I have explained, then unloading, all these things I have explained, leaching and all. So anyway, I will just go through uh, each and every changes or each and every factors in detail in the next lecture. So let us have just have a brief look. That is, first one is desiccation, second one is weathering, and the third one is consolidation and densification. The fourth one is unloading. The fifth one is orthogenesis, which is actually some mineralogical changes which will bring some difference in the texture as well as the angularity of the deposit, the soil deposit. Then sixth one is diagenesis. That is also a mineralogical change which will change, which will bring some changes in the surface structure of the soil deposit, etc. And then comes cementation. Then comes the aging effect. Then leaching, ion exchange, differential solution, jointing and fissuring of clay soils, biological effect, and finally the human effects. So these are the various post-depositional changes which occur in the sediments. So from this post-depositional changes, I will be taking in the next lecture. I will give you the video lecture in the next class. Okay, so thank you.